Yes. Good afternoon, my name is Charlotte, and today I'd like to talk to you about fine-scale habitat suitability for humpback whales in Zavora Bay, Mozambique. Now let me start by giving you some background information about the species of this study, the humpback whale. The humpback whale is a cosmopolitan species found in all oceans except the Arctic, and its global distribution is linked to a strong annual cycle where they spend the summer at high latitudes where there's a lot of prey, and then they migrate to lower latitudes at subtropical and tropical areas to breed and give birth. Now currently there are 14 distinct populations of humpback whales all around the globe, and the focus of this study lies on the East African coast genetic subunit called C1. They have their wintering habitat in Southeast Africa and Madagascar. Now, the study area of my thesis is called Zavora Bay, which you see here on the left is located on the south part of Mozambique. And on the right, you have a close-up view of the area with highlighted the part that we actually use for analysis. Now, the importance of investigating humpback whales directly relates to the number of threats that they face and the importance of regulatory enforcement measures to decrease the number of threats and increase the protection of the species. Now, this list of threats is endless, but some important ones are the direct killing of the whales, but also the occurrence of inadvertent vessel strikes and the risk of entanglement in fishing gear. Also, coastal development poses a risk, just as tourism and inadequately regulated marine traffic and whale watching activities can impose stress on the animals. Also, the habitat is directly threatened by human use, and anthropogenic underwater noise and pollutants can be introduced in waters where humpback whales aggregate. Now, the problem here also in this area is that so far there are no local, national, or regional regulations in place to help decrease the threats these animals face. Now, my idea was to provide a baseline of information in this bay of what's going on there and what's there to protect. Now, we split this research in 3 different phases. The first of being the evidence of this area serving as a functional part of the larger scale breeding ground for this population. So to what extent is the bay part of this breeding ground? Now, the second objective is related to the identification of core areas within the bay. And directly related to this one, we have the third one, called the drivers of area suitability. So we wanted to look what the driving factors are behind any observed pattern of distribution within the bay. Now, moving on to the methodology, let's start with land-based observation and maps. Ever since 2010 up until the present, a number of visual sighting surveys have been carried out. Now, on these surveys, information about the whales related to abundance, distribution, and behavior has been gathered, and at the same time, environmental variables have been gathered related to wind speed and direction, swell, sea state, cloud cover, and also temperature. Now, whenever whales are sighted, their geographical position is recorded on a hand-drawn map, which you see here. So this is a drawing of the area. And then these maps are later digitalized and georeferenced using ArcMap. A second part of the methodology encompasses photo identification. Ever since 2010, an open resource platform called mozwhales.org was launched. And since then, images of flukes of whales all along the Mozambican coastline have been assembled opportunistically. Now, all the photos of flukes that originate from within my study area have been incorporated in a program called Fluke Matcher. This is a computer-assisted matching software that assisted me with building a photo identification catalog for further analysis. Now, I'd like to show you this quote. Models are merely an attempt to simplify complex distributional patterns with a reduced set of predictor variables. It's a direct quote that I took from my report based on something Barry and Ellis said in 2006. And it's just to demonstrate that what follows is a description of the statistical design that I used, but it's a model that's not yet perfect. And I just would like to stress that I'm not the only one to make these kind of models, and they're never a perfect representation of reality. Take this into account when looking at it. So what I used is called a single species, single season occupancy model. Now, it was developed by McKenzie in 2002, and it's based on the assumption that information about abundance can be difficult to get, especially in cetacean research. Now, the alternative state variable that you can use is called occupancy, which is based on presence-absence. And in my research, this was translated to the probability of whale use of a specific site. Now, this type of modeling has a way of incorporating the chance of imperfect detection, which is also a problem often met in cetacean research. Now, the way this works, therefore, we look at the study area again. So the study area has been subdivided in a number of grid cells, which from now on we'll call the different sites. So each grid cell of 1 by 1 kilometer is a site in my model. And each site is characterized by a number of site-specific covariates, like longitude, latitude, depth of the water column, and so on. And at the same time, all the surveys that were held in this bay, so over all the sites, were characterized by survey-specific covariates. This means the month within the year where the survey was held, or the temperature of the day of the water in that survey. All this information is grouped and linked to the sightings of the whales by the means of a detection history. Now, a detection history works as follows. Whenever you see a whale at a specific site on a specific day, in the data it'll show up as a 1 and a 0 if not. Now, this detection history, like the sequence of zeros and ones, is called the detection history. Now, the link between detection history and the other information is summarized in 2 different steps, mainly the probability of whale use, so the occupancy which we are trying to identify, and a second step called the detection probability. What is the chance that if a whale is present that we can actually see it? Because that's also an issue. Both of these are based on logistic regression, like we know in general linear modeling. So a number of models is created, and based on the Akaike information criterion, the most parsimonious model is selected. Now, after model selection, we performed a goodness of fit test called the Pearson chi-square test to see whether or not there was a lack of fit between the model and the actually observed data. Now, for the results, I'd like to stress that this is just a selection of what I did due to time limitations. And also, we gathered information and data from 2010 onwards, but we were only able to use data from 2017 and 2018 for analysis. Now, for the first research question related to the importance of the bay as a breeding ground, we looked at a number of criteria proposed by Scheirat et al. In 2000, first of them being a temporal pattern of variation in relative abundance. What you see here is the seasonal change in relative abundance of whales within the 2018 season, where displayed as the average number of whales within an hour, within each 2-week period, starting from the beginning of June all the way to the end of October, which is our whale season, when the whales are actually present in the area. Now, what we see here is that there's an increase in relative abundance at the beginning and middle of July, and again, a decrease towards September. Now, following, we also looked at the group size. Now, group size showed a significant decrease from the beginning towards the middle of the season, and again towards the end of the season in the 2018 season. And there was a non-significant but similar trend in the 2017 season. Model pod size for both seasons was 2, but the group size varied from 1 up until 10 individuals. There were some inconsistencies in the data gathered related to calves, but the calf presence was undeniable. And besides that, we also had a lot of data related to behavior. Now, the most prominently observed behavior that we saw was breaching. This is important for later, just to already mention now. And then we also, I also mentioned photo identification in my methodology. We identified 51 individual whales using fluke identification images over the past decade, but none of them seem to have returned to the area. Well, at least that's what we see. We didn't see any resightings within or between the seasons. Looking at the distribution of the whales, I would like to show you the following 2 maps. On the left, you see the number of visits of whales per hour per square kilometer. And on the right, we see the exact same, only there we only look at the sightings that include calves, and we discard the other sightings. Now, what's important here is that we see that the whales are more or less equally distributed throughout the continental shelf waters. But when we look at the calves map, we see that they tend to use areas that are a bit shallower and closer to shore. Now, the statistical background behind this distribution is shown here. I know there's some equations there, and I'll talk you through them. Now, the equations on the bottom here relate to the model that we used to describe only the sightings with calves. The goodness of fit test showed that this model had a significant lack of fit with our observed data. So we now focus on the top equations, which relate to all the sightings combined. There we see that the probability of detection is influenced by both year and temperature. And then knowing this, we see that the distribution is influenced by depth and slope, but mainly by the distance to shore. Now, discussion-wise, I'd like to stress that there was a substantial amount of observational error introduced in the data assembly, which I didn't do myself, and that this causes us to interpret the results with the needed care, especially related to relative abundance. But strengthened by the undeniable presence of calves and the observation of aerial behavior, which is often related or associated to the formation of competitive groups and courtship, we do state that this area is a functional part of the breeding ground. Now, not much has come forward from the photo identification analysis, but we say that this is actually due to the extremely low effort compared to the duration of 10 years of study period. The mother-calf pair separation that we saw was actually, can best be explained by the fact that further out at sea, conditions tend to be worse, and thus the shallow areas closer to shore tend to be a safe haven for these calves. At the same time, avoidance of harassment by other males has been suggested as an explanation for this habitat segregation. Now, towards the future, singing has been observed in this area, and singing is very characteristic to breeding activity by the males. Now, we would like to confirm this by the organization of acoustic surveys, and that will learn us more about both the interactions between the individuals and the distribution and activity of the whales. Some model optimizations have to be made. Like I said, we're not perfect yet. So I would include marine traffic, which I wanted to do now, but something went wrong there. And also temperature data was incomplete this time. I would also suggest the use of an automated theodolite to ease the process of getting the geographical coordinates for the whales. And I'd like to increase the photo identification effort. This I would do by using the boat trips that are already daily organized in the area for other research. And I would like to collaborate with neighboring organizations from neighboring areas to expand our catalog and to see where our whales go from the moment they leave our bay. I would also like to use the drones that they already have available. They have the resources, but I'd like to increase the manpower to actually perform the research. And I'd like to map the collisions and strandings that are anthropogenically induced to see where our areas of importance clash or coincide with human space use. Now, to conclude my results to my earlier stated objectives, we conclude that the reproductive behavior combined with the presence of calves and the pattern of abundance gives us enough evidence to say that this bay is a functional part of the larger scale breeding ground for humpback whales in the area. We clearly saw a mother-calf pair separation, and modeling with imperfect detection showed us that depth and distance to shore were the main determinants for this distribution. We do recommend some improvements to be made before we can communicate this to management authorities in order to increase our knowledge on these priority areas. I'd like to thank my supervisor, Nakia Culane, and my promoter, Ian O'Connor, and everyone who was involved in my project, and you all for listening. Are there any questions?